Good day, colleagues. I'm Arnold Kofi, an MSc student at African University of Science and Technology, Abuja. And I'm presenting on using AutoEncoder deep learning model to improve collaborative filtering for recommender systems. So I'm going to walk you through the abstracts, methods, results, discussion, conclusion, then references. Okay. Now there are a whole lot of information in the system. Now, content creators find it very difficult to map the right kind of information to the users, and the users as well actually find it very difficult to find the right kind of information. Like going on to, let's say, Alibaba and trying to find an item, and you are unable to, you go through a kind of hassle before you get the item. So, recommend that system actually came into being to curb this situation. And the main motive of this recommender system is to recommend items, okay, that will be of interest to the users. Now, in this area of research, there are already models and there are already machine learning implementations in these models, like collaborative filtering, which centers on metrics factorization and neighborhood method. They've all been implemented here using machine learning. But these methods were faced with problems of cold starts. That is where there is lack of data and non-linearity in data representation. Okay, so the main motive of this paper is to bring in a deep learning model like AutoEncoder. Now, the reason is that deep learning models are able to, iterate through data, a couple of times or multiple times, and you're able to actually look at it well and extract the feature representations of our data. That is why we are going to use a deep learning model to work in this area. Okay, so in October 2006, Netflix actually birthed this matrix factorization thing. They actually wanted a good recommender system that is going to help them, do recommendation on their movies. So matrix factorization came into being, where there's a matrix that maps users to items, and users are able to how do I input it? Users are able to rate items, okay? But in reality, you realize that not all items could be rated by every user. So the main motive of that matrix factorization is to fill in the spaces or fill in places where there are no assessments, okay, on these items. Okay. So as I said, these methods, when there is cold starts, have issues and they are not able to learn. For nonlinear data, they are not able to look at it very well. So the main purpose here is to bring in autoencoder. Now, the objective here also is to improve the root mean squared error and reduce the train loss. Okay, here. So what is an autoencoder deep learning model, or what is an autoencoder? An autoencoder is a feed-forward neural network. So it's actually an artificial neural network, okay, that has an encoder part and a decoder part. These are the two main features of an autoencoder, or the two main parts of an autoencoder. Then in the middle of this encoder and decoder, it has something we call the bottleneck, okay? Now, for each of the encoder, for the encoder part and decoder part can have numerous layers or numerous ANN, artificial neural network layers, okay, so that it could iterate to the data a couple of times. Then the same thing to the decoder, it can also have numerous neural networks. So it means that an autoencoder can be as deep as we want it to look like. And frankly, the more deep this neural network looks like, the more better it's able to give us good results. Okay. But the concentration, we have to also put concentration on the bottleneck, because at this bottleneck, that is where the data is being compressed. Now here, it tries to actually find out which kind of data is perhaps relevant, for the next stage of the model. Okay, so if there is data here which is not needed, the autoencoder wouldn't proceed to to the next stage. Then one thing again to about this autoencoder thing is the autoencoders tries to give us similar outputs of its input, or they try to, how do I input it? Okay, so if you put in an input, The main purpose of an autoencoder is to replicate that same input as your output. So there won't be so much change. Okay. The main purpose is to bring that same data to you. Now, when dealing with an autoencoder, there are two main characteristics here. That is data denoising and dimensionality reduction. We bring in dimensionality reduction because autoencoder tries to reduce errors. Okay, so reduction of errors here relates to its dimensionality reduction. Okay. Now, we implemented this one using movie lens 1 million data sets, which consists of, I think, 1 million and 209 anonymous ratings of roughly 3,900 films submitted by 6,040 movie lens method. And we applied this in Python, using TensorFlow. And so when developing an autoencoder model, okay, there are some key attributes you need to look at. So you have to look at your loss function, you have to look at your number of layers at each node, and you have to look at the code size. Okay, so we looked at all of these ones before implementing this model. Now, we implemented a sigmoid as our activation function. Then we use the root mean squared error instead of a mean squared error for our error evaluation. Then again, in order to try and minimize, minimize the errors very well, we also brought in an Adam optimizer. Okay, that will help us minimize the errors drastically. And going through, this is the result we had. You realize that we have a train loss, we have a test loss, and we have the mean absolute square error. So you could realize that at each epoch, there is a train loss, which maps to a corresponding test loss and the mean absolute error. Now, when you look at these mean absolute error or these mean squared error differences compared to classical collaborative filtering, using machine learning, you realize there's a very big vast difference, or there's a big difference in these mean squared errors, which proves that an autoencoder deep learning model does well or does better than a classical machine learning, matrix factorization or collaborative filtering method. Now, let's come to the discussion. So autoencoders learns nonlinear transformation of data. Okay, as I said earlier on, unlike classical recommender models like matrix factorization, they're not able to learn these things. They are not able to learn non-linearity of data unless the data is linear. The data is already in a line form. That is where they can learn. Now, with appropriate dimensionality reduction, specific constraints, okay, when there is enough data or there is everything in place, you realize that autoencoders can even give data projections and are more interesting than basic techniques like matrix factorization. Same, I'll still reference to the machine learning models. Okay, so as we said, the main purpose of the autoencoder is to transport inputs to output with minimization in error. So it tries to make sure that there is, minimum possible error that will come out of its implementation. Okay, so in conclusion, you realize that autoencoder deep learning model proves to be a better model than classical machine learning models on matrix factorization or on collaborative filtering. However, there are key limitations faced with autoencoder models on recommender systems. The reason is that because autoencoder models does iterations on the data and tries to do data compression, there is lots of data at the output. So you realize that the same kind of data is not gotten at the output. So there's data loss due to the data compression. Then they are able to compress only data similar to what they have been trained on. So if it has been trained on data A, then it means that it is able to learn and do exactly on similar data. But when you use a different data altogether, it becomes a bit of a problem for autoencoder. So in the future work, we recommend that we will look at the factors affecting the data loss, when compressed, so we could improve on it. And below are my references. Thank you.